Hi everyone. Today we will take you through our journey of analyzing football passing pattern using the Oberoi code. Our project focus on analyzing a dataset of 28 players to uncover meaningful passing patterns. We worked hard to organize the data, make necessary changes to the Oberoi code, and compare our findings with the result of a research paper. This process gave us valuable insights into how the passing pattern in dataset differed from those found in the research, helping us understand team dynamics. Before we dive into this, I would like to acknowledge my group members, Farzeen, myself, Abdul Sabur, and Idris. We contributed greatly to this work. Let's get started. Moving to the next slide. For our analysis, we started with the dataset containing information from 28 players divided into two teams of 14 players each. The dataset was very detailed, including key information about each pass, such as the start and end time of the pass, the sender and receiver IDs, and the X and Y coordinate of the players. Moreover, position on the fields, the rich dataset gave us a clear picture of how passes flow during the matches. To prepare the data for analysis, we group passes based on overlapping times. This approach helped us organize the data into a structure resembling 3,000 matches. It provides a solid foundation for identifying distinct match events based on the timing of passes, making it easier to study patterns and strategies in more details. After grouping the data into 3,000 matches based on overlapping times, we needed to refine it further to make it more meaningful and manageable. We started by reducing the number of matches from 3,000 to just 28. To do this, we combined passes that had the same timestamps and accounted for substitute players who joined or left during the game. This step was crucial for removing any duplicate or redundant data while still preserving the accuracy of the player interaction. This refinement process allowed us to focus on the actual matches, eliminating unnecessary clutter by ensuring that the data was clean and well structured. We created a solid foundation for analyzing passing patterns and identifying the key strategies in the games.
Hello everyone. Just as the Farzin explained you the topic of, give you the information about the introduction in the data representation. Now I'm going to talk about the overall code that we have adopted in our code. Actually, the changes that we have actually made in the code. Today we are diving into overall code, a cutting-edge tool for analyzing the dynamic systems with a focus on passing patterns. The overall code is designed to work with the dynamic graphs where node represent the players and the edges represent actually the passes between the players. What makes it powerful is the ability to recognize evolving patterns and its ability evolving a pattern in real life, allowing us to identify structural similarities between the graph even with the specific players or different labels. The second thing is this tool leverages or give us advances the concept of dynamic graphs, which is also graph, which is isomorphism, which help us to compare teams' strategies at different times or even across matches. For example, it can detect a recurring formation like triangular passing step up regardless of the players involved. Uh, Moreover, by using the OBI code, we can analyze not just what's happening on the field, but also on the how the team strategies adapt and evolve, providing valuable insight for the coaches in analysis. Now let's see how we have adopted this code into our own code. The first thing that we modified was the code iterations loop to ensure the compatibility with our dataset structure. This step was actually essential. Uh, Essential to process our data efficiently as it differed from the example graph is provided in the original code. Now moving to the next point that we actually replace our placeholder data with our carefully prepared football passing data. This integration allowed the overrides code to analyze the real world problem to specific scenarios to our own project. Some of the data we actually collected were from the research papers. Lastly, finally, we updated the file path to ensure the seamless access to our data sets. Like there were position of the data were different given in the Obera's code, but we have to manage to access that particular data. We have to given different kind of paths. These changes that streamline the code ability to process our data efficiently and enabling us to focus the analysis itself. Lastly, with these adoptions, the Opera code is how perfectly aligned with our project requirement, ready to uncover the patterns and strategies hidden within the game. And now, moving forward, the Idris will tell you more about it.
Moving towards the data organization and target graph creation, we basically group the data based on which the team had the ball and the streak passes uh, within the one team called a possession, and when the other team gets the ball, the streak ends. Each possession become a target graph. In the end, we created 496 graphs using the text file generated from the data. And moving towards the code implementation, so, in the code implementation, we wrote the Python programs for these three tasks. The first one is of the data segregation. The first program, we group overlapping uh, timestamps into the 3,000 matches, and a second program narrowed this down to the around 28 matches by comparing and accounting the substitutes. The second one is of the graph creation, a program that took the final data and turned into the 496 target graphs. And finally is of the pass frequency. Another program calculated the how many simple single passes and complex multi-passes sequences happened during the event, and the data was turned into the graph for the analysis. So, what the results we gathered from all of this activity? We compared our graph from one research paper that is provided to us, and in the paper, single passes were not common than the multi passes. However, in our results, multi passes were more frequent. This difference showed how our data sets and approach vary from the research.